All right, let's get right into it. Today it's Saturday. We're gonna have a short little stream today. Last couple days of the jam. I'm trying to think of what I want to work on today. The um, the last thing I was thinking about is how this and this thing now feel redundant to me, and it might be possible to say okay, so section table here is actually this, right? And import tables is actually this, right? So what if instead of having this split panel here, I put the multicolored list here, right here under views, and got rid of these completely, and then these two tables would become attachments onto these markups. The section table and the imports table would get those special markups. The biggest disadvantage to that is that important stuff, like the symbol table, will end up way down at the bottom if they're sorted with this, right? And you might be interested in finding them, but if they're sorted here, then they won't be so easy to find. Hmm. Well, it's an experiment. Let's try it. Something seems really loud and noisy today. It's probably because I took the Windows sound blankets down. I did this the wrong way around. My mistake. Okay, so where is this? No. Okay. Let's see here. I'm gonna pull some stuff out to get started. Hey, Terry's Python. It's been alright. I'll show you in a sec. I'm a little bit close to that point where, like, this is feeling like it's a big long-term project. Like, this jam is the beginning of something, not just it's not lightning in a bottle, like a magic 1 week trick. It's a long-term project, and we're starting to really see that as there's lots of experiments left to run, lots of hacks left to clean up to improve how things work. But I don't mind finishing the jam up by just catching up on some cleanup, I think. So that's what we're doing. What did I miss? Right, you need the tree. Let me show you. I'm going to show you in a sec. There's a lot of big ideas coming out from this experiment. This is a project I've kind of had in the back of my mind for a long time, so getting started in 1 week and discovering that there's a lot more to figure out is not that surprising, but I do feel like there's a pretty clear sense of, like, bin dash is not quite going to be in a useful state at the end of the jam yet. And that's okay. It's just, trying to decide during a jam when to accept, like, how far you're going to get, and do you switch to, do you keep cramming in features? I mean, a week-long jam is a little bit, especially for something like this, you know, a week-long game jam can be pretty good because there's a lot of stuff to do in a game, like getting the art better and getting the music better and so on and so on. With something like this, it's just a tool. I feel like by 1 week, you've made enough mess, at least at the pace I work at and the way I do things, I've made enough mess that cramming in more features on day 6 doesn't make a lot of sense. But here, so we add this hex view, and I've got, like, ranges marked up on the hex view. It doesn't do a whole lot yet. Like, you can select these, but it doesn't do anything over here. I don't have correlation between them so that I can jump around. But as I've been looking at this, I've been thinking, like if you look here, we have header, section table. Here we have the sections and the section table again, and then each section gets listed here. And there's, I can't scroll, unfortunately, the list of these because I only have one scroll in my hacked up UI system so far. Like, if we look at one of these, you know, there's an import tables thing here, which I could go find if I wanted to. But that's gonna be, let's see, text section is big. We're in .text still. There it is. So I just entered our data, and our data is going to contain all of these. So I can't tell their subranges. I don't have a solution for ranges yet. But I also want to be able to take this, and I'm thinking, like, these are kind of redundant now. Like, obviously the table view is nice, but the hex view contains this list of ranges, and, like, the sections table exists here and here as two separate concepts. And I'm thinking, like, what can we do to unify the idea of sections? Like, I want to be able to present that they're low level, there's a range of data, and then it creates this high level structure that you can view, but I don't want them to be so separate. So what I'm moving towards is trying to put these, the markups, as the view, as the thing here under the file. And then maybe I can have ranges and sub-ranges be automatically detected if they're non-overlapping or something. I don't know yet. But for now, I'm just doing cleanup. I'm not even working on getting any of those things working. Yeah, exactly. I kind of want to. I also like the hex view is cool, but I'd also like to have like to swap a hex view out with minimap view. Don't really need this anymore, maybe. But like a minimap view that could compress it all down into like one screen, no scrolling, and just show you the like sort of where things are vertically um, mapped within the file, and then use that as the way to like see. I also want to be able to do like, when I'm looking at the hex view, I'd like to be able to see where relocations are applied. I'd like to, whenever I have a pointer in the data, right? Sometimes you have some data, and then it'll have some 4 bytes or 8 bytes that represents an offset from the beginning of the file or a relative offset from the beginning of the pointer. And there's different ways to encode a pointer in a serialized data, and I want to be able to see that, oh, this is pointed at by this thing over here. So when you're using this for diagnostics purposes, you could do something like, oh, it thinks the section table begins here because this pointer pointed to the header here, and then this much offset. So it's all off because of this pointer being wrong. Would be something I'd like to be able to just see. And then there are things like when I think about it, like, while this is all cool, there's actually nothing super specific about, executables and object files and images. These files are the ones I'm focused on, but bin dash could be a generalized binary visualization tool where all you have to do is write plugins for each file format you want to support. So if you end up being like, hey, I'd really like to be able to visualize, the internals of my asset format that is custom to my game engine, or these, I've got a Photoshop file that I'm trying to write an importer for into my game engine, or whatever the case might be. I'm building my own operating system and my executable format is different. Whatever the case is, I think it'd be possible and cool to make a plugin system out of this, which was one of the goals I had. And I'm realizing that it could be a plugin system that goes beyond just executables and objects. Okay. So for my first move, I've pulled out those table generators that I have, and I've removed everything else. Now, what I actually want to do, now that I've saved the useful code into separate functions, what I actually want to do is I want to say the parse markup nice. There we go. That'll work. Okay, so I actually can fit all of them in here. Although they're not sorted. Okay, so this brings out the question I was talking about at the very beginning of this, which is if having them sorted is nice, because then, you know, it's more correctly reflects the structure of the file. But there we go. There we go. Okay. So now I've put all of those in on the tree. The problem now is none of them have any of the useful visualization stuff attached, right? And I also don't have my hex view anymore. So let's do a couple things here. I'm going to say that from now on I want to just attach, I want to just set the color on a tree directly. So when I make a new tree, that'll be a 0 by default, but then I'll do, let's see, you know, I'll just like a color index kind of thing, and then we'll do new tree, or tree new. It'll start off like that to mark it as unset. And then when you make a tree, set that. And when we do tree display, if the tree's color index is less than max U32, then the color will be derived from the color wheel in the UI, like so. There we go. Okay. Okay. So what I want to do is I want to put the hex view on the right side here. Okay, we're going to try to put the hex view right over here. Okay. right, that's that kind of markup. All right. Okay, close, but I want to change the markup renderer to not put this thing in now. Right. Kata Mui says, hey, have you ever dealt with pointers of pointers? I find it a bit complicated to understand. Yeah, pointers of pointers aren't... I can understand why it's a little bit mind-bending, but it's not only have I dealt with them, but there's nothing magic about them. They're not different from pointers. We can talk about it if you want. I can give you the lowdown. But why don't you tell me, like, how you get lost along the way, rather than me guessing at what's hard about pointers to pointers? Why don't you tell me what you think about pointers, and then I can respond to where you're actually at better. How does that sound? All right, so I can scroll my hex view. Now, maybe I want the hex view. I don't know. Maybe not. The next thing I want to figure out is if I'm gonna have these here and correlate them with this, do I really want these to be so far apart from each other, or do I want the hex view right here and then put the table view on the far right? I feel like that would be better. Let's swap the hex and main view real quick. You can start to see where, like, I am desperately needing an automatic layout system for my panels. No. It's a great question. Okay. Let me finish what I'm doing, and then I'll talk to you about pointers to pointers. See if we can help you out. I'm not sure what you mean, Husam. That doesn't. The syntax you're providing is skipping a bunch of syntax. I don't really know what you're suggesting that they're asking. I think you're talking about swapping out the x parameter in their example. Are you talking about the parameter or the variable? Like, there's a lot of assumed context that makes your statement make sense that may not be the same assumed context that everyone else has. You know what I mean? So we got to build up that context together to have the discussion. Okay, here we go. Boom. That's not right. How did that happen? Okay. Tree x0 equals. Yeah, it's a function call, but the missing context is like, what are x and y? X and y were parameters in the example that Kata set up, but it looks like they're local variables, or some kind of variable to the function call in yours. And we haven't established if the swap function is going to be pointers to pointers, or if it's the variables that are pointers to pointers, right? Which thing is a pointer to a pointer will change what syntax we have to use to talk about it. And we're just going to make things more confusing if we keep talking in incomplete context. It's all right. It's all right. We'll get to it in a sec. Hex. Okay. X0, X1, X0, X1. Okay, what is this? What is going wrong here? So that's all yellow. Feels like one of the splits must be wrong. From tree hex goes from tree x1 to hex x0. Tree x1. There we go. Okay. Very cool. So now I want to be able to attach some tables. We'll do that next. All right. Let's talk about pointers to pointers. So there are a couple of different levels here, right? Level, there's the, let's say the memory level, which we need to talk about. There's the syntax level, and there's like a concept level. So memory level is like what's happening inside the memory of your program when you create variables and we create pointers. And the syntax level is what is the syntax of C related to creating those pointers and using them. And then the concept level is what is being achieved by this, right? So let me read again the confusion point. If we pass pointers, we pass them as swap. If we pass in normal ints, we pass them as swap. So pointers, I understand, not an issue. But a pointer of pointers, it means that X is pointing to another pointer. So how would that look in the swap example? So here's the concept, right? We have a swap function, right? The swap function looks like this basically, right? So we're gonna have like t y equals x, or x equals y, y equals t, right? So our swap function is going to be implemented by reading out of x, writing from y to x, and then taking the temp back into y, right? So there's a simple swap implementation. And you can see here, this is the implementation side. here is the usage side. Let's build up that context we're talking about. So let's say we have foo equals 10 and bar equals 55, and then we swap foo and bar. Right, so that would mean that if we were to print this, we would then expect foo equals 55, bar equals 10, right? Okay. Now, at the memory level, what happened here was, let's look at the usage side. I have 4 bytes that make up, so let's call this 4 bytes that make up the variable called foo, and another 4 bytes that make up the variable called bar. So I'll label them. Remember, in memory, memory doesn't have labels. The labels exist during the compilation. The compiler uses them to track where its different little places in memory will go and line them up, so the places where you set them and the places where you use them line up through the name. But in the computer, when it's actually running, variable names don't exist anymore. It's just this memory location, right? And so what happens if we say there's a 10 living here and a 55 living here, when we call swap, each of these has an address. So we might say that the address to these are, I'm going to use hex notation here, and we'll say that the addresses are 10 and 14 in hex notation, right? So these are the addresses. These are variables. This is memory. And these are addresses. So when we call swap, we're essentially calling the call to swap is essentially this, right? That address and that address get passed here and here, right? And then the swap function has the effect of doing this. It does not change the variable labels. Foo and bar stay in the same spot. It does not change the addresses because those variables can never have their address changed. Variables, wherever they are put, they stay there. You know, local variables have fixed addresses for the entirety of their existence. But the values in the memory get swapped by the function, right? So that's how swap is working, and we're all good on that part. Now you're asking, your confusion is, what happens with a pointer to pointer? So if we were to try to introduce a pointer to a pointer into this, the hard part is we don't have any reason to do that. Like the goal here is to swap foo and bar. If we wanted to, what we could do is we say, hey, swapping 2 integers isn't what we're interested in, right? I think the useful way to make an example here is say, let's say these weren't integers. Let's say foo and bar are actually pointers, right? So I have a foo and I have a bar, and they get set by some logic previously, and so they look like this now, okay? And when I go to print them, now that they're pointers, I will print them with this. So let's say, let's just put in what addresses. Let's say foo contains the hex address 100, and bar contains the hex address 250, okay? So when we swap, what we would expect is OX250, OX100. Does that make sense? Like, I've changed from, I'm only looking at the usage side here. Instead of swapping 2 integers, I now have 2 integer pointers. So now when I take an address of one of these, I'm getting a pointer to a pointer, right? This is a pointer. When I take the address of a pointer type, I get the pointer to pointer type. So now I would have to update this and say, well, swap, the purpose of the swap function is actually going to be to swap pointers. So the only thing that changed is these are now pointers to pointers. And this right here became a pointer because the types were swapping. We were swapping to ints. Now we're swapping to pointers, right? Now a pointer, let's update our memory level view. We still have foo and we still have bar, but let's say we're in a 64-bit machine. I think that'll make this a little clearer. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 bytes in each pointer, because in 64 bits, it takes 8 bytes to express a pointer. So my addresses are now 0x10 and 0x18. Right, so if these are my addresses, and you notice I made this 8 because it's 8 past this instead of 4 past this. So my variable types have changed, which means the memory is bigger for each variable, and the layout the compiler gives them will be different. And so when I call to swap, I'm actually calling this, right? And it's now swapping to integers, which are 8-byte variables. So the swap is a swap of 8-byte values, right? So this, let's put in our values here. This is OX100, OX250, right? So after the swap, this would be the 250 and this would be the 100. Okay? So what I've done here is I've rewritten swap to be a swap of integers. So I've changed the function. You could no longer use this to swap a pair of integers. It's now for swapping a pair of integer pointers. And that's what the memory view is showing us. Okay? So I don't know if that answers your question or not, but that's the way that I think you want to be viewing this, is a pointer. How it looks in memory, what address it contains is just a value. It's not that different. Right, so a pointer, when you have a pointer variable like this, it's just a variable. It just contains some value. The type of value is different. Integers contain integers, right? Something between 0 and 4 billion-ish. Pointers contain addresses. They're a different type of value. They're still represented ultimately in memory as just bits, but in the type system, they are different from a integer, right? A pointer contains a value called an address, but it's just a variable. So a pointer to a pointer is another level of removed from that. Like this pointer to pointer is a pointer to some variable, some spot in memory. And that spot in memory, when we dereference it, when we do *x, now we're getting an int pointer, right? We're getting each level of pointership tells us that when we dereference this, we get one step closer to that base type. And when we dereference all the way, what we'll find is a 4-byte integer. But each step of the way, we're sort of chaining through a series of pointers to get there. Now, the important thing to notice is that the size of a pointer is always always the same no matter what it's pointing to, right? Pointers contain addresses, and an address is the same size no matter what type of pointer it is. Yeah, what Brandon Mick is saying is also important. So all pointers are basically the same thing, except that the type system lets us mark up our pointer, right? You can think of all of these as just being a pointer to something. They're just addresses. They're just pointing to somewhere in the memory. What we do with C is we don't make all of our pointers look the same. We say, when we dereference this, what will we expect to find? That way we can track through and make things match up. That's all of the pointers are doing. If you want to, you can say, hey, I want a generic type of swap where I can put in anything, and I'll tell you the size of the swap. So the point here is that the type system before was giving us a fixed idea of what the size would be. But with a trick like this, what we would end up doing is we'd have to have some kind of like a buffer, and we would copy into our buffer from X using the size, and then we would copy into Y from X, right? It wouldn't look the same anymore because we've thrown out the type system and we're doing it manually ourselves. That makes it look different. But it has the advantage of being flexible, whereas this, it always has to be swapping the same type. I don't think that's a bad thing. So the question is it okay to always pass everything as a pointer? Um, that's not a bad thing. It's not necessarily the best thing to do. So, um, if you have a big struct, so let's talk. Let's clear out what I've got. We have some function. Let's say you have a my struct, and you're gonna pass it like this. If my struct is a big struct, then making this a pointer is a really good thing to do, right? If this is a kilobyte, if it takes 1,000 bytes to represent one of these types, then when you pass it by value, the compiler, what it does is it generates it generates code that will copy the whole struct so that the caller and callee have different copies. If you make it a pointer, then you can pass the original, right? Instead of passing a copy down, you just pass the address to the original. Now, what Brandon is saying is important. It's good to know this. Once you've created a pointer, there's an advantage and a disadvantage. The advantage is the argument now is just this 8-byte address. So it's not free, it's still an 8-byte address, but it's cheaper than this if this happens to be huge, right? It doesn't have to make a copy anymore. It also means that if this makes a change, right, if this goes like this change is now affecting the original. Whereas if you do this does not affect the original. So it's not morally equivalent, right? They don't do the same thing necessarily. I'm sure you already know that. But that just means, like, this is why some people like to use const. Like, you go like, hey, I promise I'm not doing something like this in the function. I don't bother. If I have something, I generally know what is and isn't supposed to be changed by value. Like, I will tend to use things like, if I have, like, my string 8 list out, when I mark something as out, or if I have, like, list out or whatever, I mark something with the word out to specify that it is going to be modified. There's output coming back from this. I don't always do that. Sometimes I don't do it, and when I should. But you can do stuff like that to mark it as well. But there is, like, a limit. Like, if you have int, passing all of these as pointers because you don't want to pass by value would actually make it worse. So, like, if you have some function that takes these as values, and this is already working, if this works, that's true. So Hussam points out, if I did my struct star putter, if I put the const here, let's talk about this. Const is silly, I don't use it, but if I did this wouldn't compile, okay? Because this is a pointer to a constant my struct. You can actually put the const here if you want to mark the star as a constant, right? So that makes the pointer constant. This is complicated stuff. Don't worry, don't even bother, okay? But there is, like, 2 different ways to mark the constantness here. Well, okay, let me point out, if you're trying to ask what's the best thing to do, if you're just learning pointers, do whatever you want. Like, when you're learning, play around. As long as you know you're learning and you're not, going around telling people you did the best thing ever. Be honest. You know that you're learning. It's important to represent yourself with a certain amount of humility when other people are going to look at what you did and take it the wrong way. That it's just good to know where other people are coming from. But if you want to know what's best to do, if I have a function like this and it does some work, and then maybe it returns something at the end, right? Who knows what it does? If this is already working with just integers, making these pointers will actually slow things down. Because here, what'll happen at the very lowest level, and you're not actually asking about what's happening at the very lowest level. I'm just saying at the very lowest level, the compiler is going to put each of these right into a register, right? At the lowest level, work gets done on the computer by loading values out of memory into registers, applying operations on those registers, and then writing values back out to the memory, right? And so when you call a function, whatever the arguments are, they are in registers. If you have a lot of arguments, they start spilling into memory. And if you have big arguments like a struct, those spill into memory. But small things like an integer or a pointer fit into a register. And so these would all fit in a register. And so if whatever work you're doing here would just directly operate on registers. If you do pointers, now each of those operations, you know, say you had to write this, right? Let's just make an example. Now the compiler is going to have to generate 3 memory reads to create local values, to pull the values into registers, then work on the registers and fill R and return that. Whereas if you didn't have the pointers, the values just started off in the registers, and it will run faster that way. But if that's not what you're worried about, if you're just playing with pointers to learn them, do whatever, you know. Step through everything in the debugger too while you're learning pointers. While you're learning, step through everything in the debugger. That will help you a lot too. If you don't have Visual Studio or Remedy or Rad Debug or something, I recommend doing that. All right, that's my cue to wrap up in a minute here. Let me do one more thing. We have... You'll get there. You keep learning, you'll know what I was talking about someday. Yeah, this is very low-level stuff. I'm talking about how the computer works related to the syntax of the language. Right, I was dropping down to registers view, which is below the understanding of even what memory is. So what I haven't finished that I need to do is I want to put the table views back in, and I have to do that right here. So I'm going to have to just stop right there for now. The next step is, once I've gone and marked all of these, somehow I need to figure out where these table views get attached onto these markups, and I don't know how that's going to work. So that's what I'll be working on probably off stream or tomorrow on stream. All right? But with that, thanks for coming around and hanging out. I'm going to wrap up for today, and I will see you all around the internet. Bye.